In this video, we will derive two new constant acceleration equations of motion. We already know the velocity time and position time equations as shown. However, we can combine these to get rid of either the time, delta t, or the acceleration a, and get two new equations of motion that can be useful in solving problems that would otherwise take multiple steps. Let's do the time independent first. In order to get rid of the time, we need to solve for the time interval using one of the equations and plug it into the other. Since the position time is quadratic in time, it is much easier to solve the velocity time equation. We will start out by solving for t. When we do that, we find that the time, the time interval delta t is the final velocity minus the initial velocity divided by the acceleration. Taking this expression for delta t, we can plug it into the position time equation. This is already a expression without time, but it is not in its simplest form. So now we will do some algebra in order to make this into a simpler form. First, I will replace this final position minus the initial position with the change in position delta x. Second, I'm going to distribute the initial velocity into the parentheses for this term, and I'm going to FOIL out the second expression squared. We can see that we have two terms with a final velocity times initial velocity over the acceleration, one with positive, one with negative. These will cancel each other out. Furthermore, we see that we have a negative v initial squared over 2a and then a positive 1/2 v initial squared over 2a. I can combine these two to get a negative 1/2 v initial squared over 2a. And then finally, we write the expression in the form that is more familiar. And this is what you often find written in textbooks, that the final velocity squared is equal to the initial velocity squared plus twice the acceleration times the distance traveled during that acceleration. For the acceleration independent, we can do something similar, but instead of solving for time, we solve for acceleration. Plugging this in to the position time equation will give us the expression that we are looking for in this case. Expanding out the term in the with the parentheses gives us final position is equal to the initial position plus the initial velocity times the time interval. We have a time interval squared and a time interval in the denominator in the third term. Whenever we multiply that out, that'll only give us the time interval up in the numerator, and so we get plus 1/2 v final, not squared, v final times delta t, minus 1/2 v initial times delta t. We have a positive v initial delta t and a minus 1/2 v initial delta t. That simplifies to give us the acceleration independent expression, where instead of having a term with the initial velocity and the acceleration, we now simply have the average velocity during that interval. These four equations that we see up in the upper left corner are the constant acceleration equations of motion that we can use to solve almost all problems.